So my name's Alan Rose, and I established a company, Corrdesa. What we do, we've been developing tools and workflow and data to enable corrosion prediction using computational techniques. We do a lot of federal work. We do work for the Air Force and the Navy, looking at how to help them with material selection and sustainment, what materials to use, what materials not to use, so that you don't get accelerated corrosion from galvanic effects. 80% of galvanic corrosion events can lead to structural failures. So that's like $2.5 trillion worldwide, $250 billion in the US, and then when it comes down to the DoD, that's like $22 to $25 billion. That's how much corrosion costs and the maintenance towards that. So just with the Naval Air Fleet, who we work with, that's $6.5 billion. And about a third of that can probably be prevented right from the get-go by better design and material selection. We use our own code as a kind of a 1D level, and then we use the Siemens software for a 3D deep dive. I think the best thing that we can deliver to our customers is, rather than them waste 1,000 hours testing materials, cut and try, oh, try this coating, wait another 1,000 hours. Well, if you can just characterize them, it just takes 1 day to characterize in the lab. And then if you combine that with the corrosion modeling capability, you can then, it only takes a few minutes to run some of these models. It's also non-destructive. If you're testing materials, you just make them rust, and that's that. But with computer simulation, you can just do it again and again. And why I picked Simcenter STAR-CCM Plus, because of the multi-physics capability, I can on the fly calculate electrolyte thickness, on the fly choose the correct polarization, material data, and then on the fly calculate corrosion rate distribution. By hooking into a well-respected code, the manual is what, 12,000 pages long? And it's been verified and validated for other cases, so it's a tool, it's out there already. So there's very little question about the V&V in terms of the numerics. It's just a new application. We've shown, for instance, an incorrect material choice in the fixing of a part on an F-18. And with a simulation, you can show that an alternative material is much, much better. Although that material itself is more expensive, it just virtually eradicates corrosion. So I don't know what the monetary value is, but when you think about the operators that have to exchange a lot of bushings in these holes, and there's thousands of them, and they've avoided that, or they don't have to do it as often because we now know of a better material choice, I would easily think you'll be saving millions.